Welcome to this explainer. Let's skip the sci-fi tropes today and dive straight into the massive, gritty, trillion-dollar industrial machine required to actually build the intelligence age. People talk about AI like it's just software, right? Just algorithms floating around in the cloud. But the reality is literally heavy. It's tangible, and it demands an astronomical amount from our physical world.
We've got to start by tackling that popular doomer narrative. NVIDIA CEO Jensen Huang absolutely nailed this when he called the apocalyptic sci-fi anxiety over AI a complete disservice to society. He pointed out that this Terminator mindset, the whole, oh, there's a 20% chance AI will end humanity thing, is just pure nonsense. And honestly, it totally distracts us from the monumental physical shift happening right under our feet.
So instead of worrying about some mysterious, self-aware software suddenly walking out of a server room, this explainer is going to show you how the AI boom is actually the largest physical infrastructure build-out in human history. We're talking concrete, steel, massive earth-moving machinery. This isn't just a digital revolution, it's a heavy industrial one.
Section 1. The 5-layer cake. Building the physical foundation of AI.
To really wrap our heads around the scale here, Jensen Huang uses this fantastic framework he calls the 5-layer cake. It's perfect for mapping exactly where trillions of dollars are flowing. Look, everyone gets distracted by the frosting on top, right? The models like ChatGPT, the slick applications, but a mind-blowing amount of capital and physical labor is being poured into the foundation: energy generation, chip manufacturing, and massive data centers. Without those bottom 3 layers, the top 2 literally do not exist.
And this perfectly illustrates that bridge between digital intelligence and physical power. It's a stark reality check. To generate tokens and produce AI at any meaningful scale, you are fundamentally dependent on massive power grids and heavy industrial engineering. You simply don't get abstract digital thought without burning raw physical energy.
Section 2. Securing critical minerals. The dirt behind the data.
Okay, so the true bedrock of this entire AI revolution, it's not code, it's the Earth itself. There are exactly 60 critical minerals that have been explicitly designated as essential to both the economic and national security of the United States. Think copper, silver, rare earth elements. We are going to need exponentially more of this stuff to feed the massive hardware beast that AI requires.
But here's the catch. The mining industry is facing some brutal headwinds. We're currently seeing a 25 to 30% decline in ore grades per decade for major commodities. What does that mean for us? It means operators have to move exponentially more dirt, literally mountains of it, just to maintain their current production levels, let alone scale up for AI. So operational costs, energy consumption, environmental footprints, they all skyrocket. It is a massive physical bottleneck.
Section 3. Heavy industry autonomy. AI on the ground.
So how do we overcome those severe physical constraints? Well, heavy industry is fighting back. And not by using AI to write polite emails. They're deploying it as an autonomous industrial powerhouse. Picture a massive driverless drill out in the harsh environment of the American West. Autonomous haulage systems in surface mines are already delivering 15 to 30% productivity gains over traditional manned operations. No shift changeovers, no meal breaks, optimized routing with zero human fatigue. These autonomous beasts are running 24/7. This is AI out there doing the literal heavy lifting in the dirt.
And it goes way beyond just driving. It's about listening to the machines. Predictive AI models are constantly ingesting continuous sensor data, stuff like vibration signatures and drill parameters, to catch anomalies before they happen. This proactively cuts catastrophic, unplanned downtime by up to 50%. Out in these incredibly harsh, remote environments, that kind of reliability is an absolute game changer.
Now, as we're pulling these minerals out of the earth to build our infrastructure, we're also totally rethinking where that infrastructure even lives. Take Microsoft's Project Natick Phase 2. They proved you can manufacture and deploy modular subsea data centers in under 90 days. From the day they said, let's build it, to dropping a 12-meter pressure vessel packed with over 800 servers 117 feet deep into the ocean off the Scottish coast. 90 days.
And the results were honestly astonishing. Operating down there in a dry nitrogen atmosphere with absolutely zero physical human intervention, running entirely lights out, their failure rate was just 1/8 of their land-based equivalents. By taking humans completely out of the equation and using the ocean for passive cooling, the physical infrastructure actually became massively more reliable.
Section 4. The white-collar shift. Abstract legalities versus physical constraints. Let's contrast that gritty, constrained world of physical mining
with the sterile, highly specialized, and crowded world of white-collar legal compliance. We have this staggering labor disparity right now. America produces roughly 30,000 lawyers for every 300 earth miners. Let that sink in, 30,000 to 300. Yet even with all those lawyers and legal unemployment sitting at a razor-thin 1.4%, the sheer volume and complexity of modern regulations are completely outpacing human capacity.
To bridge that widening gap, AI agents are stepping right into the compliance lifecycle. In the early stages, these agents are constantly identifying, ingesting, and mapping controls across massive frameworks like GDPR, HIPAA, and SOX. They can instantly spot compliance gaps and overlaps in real time. It's a task that a human team just physically couldn't keep up with, given how fast regulations change.
And they're doing way more than just reading documents. In multi-agent environments, like LegalSim, AI actively hunts for procedural loopholes. By simulating how rules could be exploited and running pre-deployment red teaming inside a rules as code sandbox, these systems are actually hardening our legal procedures before they ever hit the real world.
Analysts have coined a brilliant term for this cognitive augmentation, the daily forklift. Whether it's mapping complex GDPR policies in a pristine office building or routing a 400-ton autonomous haul truck in a dusty open-pit mine, AI is quietly elevating us. It's offloading the routine heavy lifting in both abstract law and physical dirt so human labor can scale up to handle higher-order complexities.
Section 5. The Sovereign Tech Base. National security as the ultimate driver.
Ultimately, these two wildly different worlds, gritty industrial mining and specialized digital legal spaces, converge on one undeniable imperative: national security. The ability to synthesize computational intelligence with modern physical power systems, that is the new metric for global strategic dominance. It's no longer just about who has the biggest standing army, it's about who controls the energy, the critical minerals, and the massive data centers fueling AI.
Jensen Huang made this point incredibly clear. He noted that this technology is no longer just some innovative software tool to make our lives a little easier. No, it is a national treasure. It is the absolute foundation of a national security infrastructure base for the U.S. government. Securing the tech and the physical resources required to run it is now literally an existential priority.
So, the crucial takeaway from all this source material is that the true bottleneck for AI isn't the software, it's not the models or the clever algorithms. The real bottleneck is the physical accumulation of power grids, massive compute centers, and the grueling, heavy industry extraction of those 60 critical raw materials from the Earth. The intelligence age is, fundamentally, an industrial age.
As we watch this multi-trillion-dollar supercycle unfold, we really have to look past the chatbots and the sci-fi doomerism. We are in the middle of building the most resource-intensive infrastructure in human history. So I'll leave you with this. As these digital mines scale up to consume our physical world's power and minerals, who will ultimately control the gritty industrial base that keeps them alive? Something to think about. Thanks for joining me on this explainer.